Grab your pen, drop down the key points calmly as I explored all I could and I really delivered the most important concept today. I admire you all for the fact that you actually make time to listen to this because you deserve better in your preparation. And you invest your time in learning to something that can truly help you. Definitely by the end of this video, you are automatically including a lot of wonderful progress in your preparation. And now coming to today's topic, that is on non-exact differential equation. There are actually five methods of solution methods, and the fifth method here is, so we have to calculate g of y is equal to 1 by m times of dou n by dou x minus dou m by dou y. So here we use the integrating factor e power integral g of y into dy. So if you multiply with this integrating factor, this non-exact differential equation is going to turn as an exact differential equation. And this topic is from differential equations of first order and first degree. So here are the three problems which are flashing on the screen, which are very, very important and easy to learn. And let's get into the video. So the first question here is xy cube plus y into dx plus 2 times of x square y square plus x plus y power 4 into dy is equal to 0. See, first of all, whenever a question flashes, so we have to consider this equation as m dx plus n dy. So clear. So as this is the question of the type m dx plus n dy is equal to 0, clearly m is this one and n is this one. So I'll take m value. So what is our m value here? M is nothing but x y cube plus y, and what is our n value here? So if I multiply with 2, this will be 2x square y square plus 2x plus 2y power 4. So the first thing what we have to do is, so we have to make a derivative with respect to y for m. So dou m by dou y value is equal to, so for here is the y cube. So what we'll do, that is 3y square into x, and for y the value here is 1. So I have to make a derivative with respect to x for n. So this will be 2x, 2 2 is a 4 into x into y square. For x it is 1, this value is 2. So here what we have to do, so we have a formula ready as g of y is equal to, see, g of y is equal to 1 by m times of, see, this is dou n by dou x minus this value is dou m by dou y. So here is the one thing that, so first of all, if dou m by dou y not equals dou n by dou x, we have to suppose that it's a non-exact differential equation. So there are five solution methods. See, please closely observe this question here, as this is not a homogeneous differential equation, as there are four variables here, one variable here, four variables here, 1 and 4. So the variables are not equally distributed, and therefore, so if it is non-exact and it is a homogeneous, 1 by mx plus ny value fails. And we have to check whether any formula is inserted in this. So there is no formula inserted in this question, therefore by inspection method also fails. So here the third option here is whether the question is in the form of f of xy into y dx plus g of xy into x dy. So the question also fails, and 1 by mx minus ny factor also fails. If you observe properly, dou m by dou y and dou n by dou x, so here are the like terms. So xy square term and xy square term, here is a constant and here is a constant. There are only two possibilities of calculating f of y and g of y. So here is the shortcut which you have to select is whether m is smaller or n is smaller. So m value is smaller. So first of all, we have to choose 1 by m times of. If it is m, go with n. Dou n by dou x minus dou m by dou y. So just we have to calculate this value and see what happens here. So g of y value is equal to, what is m here? So m is nothing but x y cube plus y, and dou n by dou x value is this one, that is 4xy square plus 2 minus dou m by dou y value is 3xy square, this is minus 1. So here g of y value here will be 1 by, if I take y common, this will be 1 plus xy square. So 4 minus 3 is value is 1, that is xy square plus 2 minus 1 is 1. Clear? Now I can easily cancel these two, and g of y value is 1 by y. Now what is the integrating factor? So now the integrating factor value is So if value is equal to e power integral g of y into dy. So which is equal to e power 1 by y into dy, which is equal to e power log y. So the value here is y. Now the integrating factor is y. Now if I multiply equation 1 into integrating factor, this non-exact differential equation is going to turn as an exact differential equation. Non-exact going to shift as an exact differential equation. What is equation 1? So equation 1 is nothing but the question itself. So what is the question? See here, the question is nothing but xy cube. See, this value is xy cube plus y into dx. Clear? Plus 2 times of, if I multiply with 2, this will be 2x square y square plus 2x plus 2 into y power 4 into dy is equal to 0. So this is equation 1. So if I multiply with an integrating factor as y, so if I multiply throughout the equation with y integrating factor, and this is going to turn as an exact differential equation. So if I multiply, this will be x y power 4 plus y square into dx, and if I multiply with y, so this is going to become 2x square y cube plus 2xy, and this is 2y power 5 into dy is equal to 0. As this question is of the form m dx plus n dy, so this is of the form m dx plus n dy is equal to 0. So here the solution, what is the formula here? For an exact differential equation, integral m dx plus integral the terms not containing x, the terms not containing x in n of dy is equal to 0. See here, if I substitute all the values here, so what is integral m? So this value is m here. So this will be x y power 4 plus y square into dx plus the terms not containing x. There is x term, there is x term, and this is the only thing where we don't have x, that is 2 into y power 5 into dy is equal to 0. So if I make an integration here, so with respect to x, here is x, that is x square by 2 into y power 4, and y square is a constant, and integral 1 dx is x, and here this is 2 into, this is y power 6 by 6 is equal to c. So here if I write it properly, this is x square y power 4 by 2 plus x y square plus y power 6 by 3 is equal to c. So here if I take 6 as an LCM, this will be 3x square y power 4 plus 6xy square plus 2 into y power 6 is equal to c. And therefore the solution here is 3 times of x square y power 4 plus 6 times of xy square plus 2 into y power 6 is equal to c. And this is the solution for the first question here. As it is very simple if you go through, and you can clearly identify which method to be used and how to be used. And see here, the second question here is, first, if you observe this one, the question is in the form of m dx plus n dy. As it is m dx plus n dy is equal to 0, so we have to take m value and n value. So what is our m value here? So m is very clear, as this is y power 4 plus 2y. What is our n value here? So throughout the equation, that is xy cube plus 2 into y power 4 minus 4x. So if I make a derivative with respect to y for m, that is dou m by dou y is equal to, so this value will be 4 times of y cube, and for y it is 1, the value here is 2. So if I make a derivative with respect to x for n, so x is 1 here, this is y cube, and here this value is 0, and this is minus 4. Clearly, if you observe, dou m by dou n value not equals dou n by dou x. Clear? So here dou m by dou y not equals dou n by dou x, and it is a non-exact. As it is a non-exact differential equation, so we have 5 types of solution methods. So for the 5 types of solution methods, which method should be used? So we have to go for the question here. As this is the question, we have to check whether any formula is inserted in this. in order to solve. So there is no formula can be inserted. And the second thing here is, are they homogeneous? No, there are four variables here, one variable here, not uniformly distributed. It's not homogeneous, and therefore 1 by mx plus ny fails. And the next one, if the question is it in the form of f of x comma y dy plus g of xy into x dy? No, this is of the form. This is not of the form. Therefore 1 by mx minus ny fails. And here is the last option, that is fourth and the fifth method. So here, which one is the smaller one, m or n? So m is the smaller one, just I'm going with g of y. See here the formula for if I want to calculate g of y. So as m is smaller, so I'll take 1 by m first, and if I start with m, we have to go with n, dou n by dou x minus dou m by dou y. So if I calculate g of y here, so g of y value will be 1 by m times of, what is m here, y power 4 plus this value is 2y. What is dou n by dou x? Dou n by dou x value is y cube minus 4. This is dou m by dou y minus, this is minus 4y cube minus 2. Clear? And therefore we can write this as g of y value as, if I take y common here, so this will be y cube plus 2. So here in this is minus 3y cube minus 6. And therefore g of y value is equal to, if I take minus 3 common, this will be y cube plus 2. And here in the denominator, this is y times of this value is y cube plus 2. So if I cancel this one, this will be minus 3 by y. So g of y value is equal to minus 3 by y. And therefore what is our integrating factor now? So integrating factor value is equal to e power integral g of y into dy. So which is equal to e power minus 3 by y into dy. So which is equal to minus 3 log y, which is equal to 1 by y cube. This our integrating factor is equal to 1 by y cube. Now equation 1 into integrating factor. So if I multiply equation 1 with the integrating factor, this non-exact differential equation is going to change as an exact differential equation. What is equation 1? The question itself is the equation 1. See here, this is the question which is equation 1. So this value is y power 4 plus 2y into dx plus this value is xy cube plus 2 into y power 4 minus 4x into dx is equal to 0. So as this is an equation 1, now I am going to multiply throughout with 1 by y cube. So this is 1 by y cube. Now what happens here, if I multiply, so this value is going to become y power 4 by y cube plus 2y by this value is y cube into dx plus this value is xy cube by y power 4 plus 2y power 4 by y cube minus 4x by y cube into dy is equal to 0. So this value is dy. So this value is dy. And now see here, so it is also very simple. So if I cancel this one, so this value is y. So if I cancel for square, so here if I cancel 3, so there remains 1. So if I cancel for cube, there will be 1. So here, so this is the equation here. This value is y plus this value is 2 by y square. 2 by y square into dx plus, and this value is x by y plus this value is 2y minus 4x by y cube into dy is equal to 0. So as I show you, the solution for this value is integral m dx plus the terms not containing, see the terms not containing x in n of dy is equal to c. See here, so here is the formula m. What is m here? That is y by 2y square into dx plus the terms not containing. So here is an x term, here is an x term. It is only 2y which is not containing x, dy is equal to c. So what is the solution for this with respect to x? So with respect to x, y is a constant, therefore we can write as xy, and here too y square is a constant, we can write x here. This value is 2, y square by 2 is equal to c, and therefore the final answer is xy plus 2x by y square plus y square is equal to c. And this is how we have to solve, and this is the solution. And the next question here is also very simple, very easy to solve, and definitely you can involve in solving. And what is this we have to do? So if the question is of the type m dx plus n dy is equal to 0, so we have to select m and n. So what is the m value here? So m is very clear as, see, m value is very clear as this is 2xy plus e power x. And what is our n value? This is minus e power x by y. So I have to make a derivative with respect to y for m. That is dou m by dou y value is, for y it is 1, this is 2x. So this is dou n by dou x. This is minus e power x by y. And clearly dou m by dou y not equals dou n by dou y. So here dou m by dou y not equals, the value here is dou n by dou x. As both are not equal exactly, this is a non-exact differential equation. This is a non-exact differential equation. If it's a non-exact differential equation, there are 5 solution methods. So please check this one. So here no formula is inserted, therefore by inspection method fails. So they are not uniformly distributed, variables are not uniformly distributed, as it is not a homogeneous differential equation. 1 by mx minus ny integrating factor fails. So this question is not in the form of f of xy into y dx plus g of xy into x dy. So this is not of the form, therefore 1 by mx minus ny fails, and there are other two options, only fifth one and fourth one. So here if you see, if you observe this one, so which one I am going to select? So g of y I am going to select. So g of y is equal to, this is 1 by m times of, this value is dou n by dou x minus the value here is dou m by dou y. So if I go with this, see, g of y value is equal to 1 by m, that is 2xy plus e power x. Dou n by dou x value is this one minus e power x by y minus this value is 2x. So g of y value is equal to, if I take y as an LCM, e power x minus 2xy by y into here, this is 2xy plus e power x. So if I take minus common here, this is e power x plus 2xy by y times of, this value is e power x plus 2xy. So if I cancel this one, g of y value is equal to e, so g power x value is equal to minus 1 by y. So this value is minus 1 by y, and therefore our integrating factor if is going to be e to the power of integral g of y into dy. So here the value here will be, if value here is e power integral minus 1 by y dy, which is equal to e power minus log y, which is equal to 1 by y. And therefore we got the integrating factor if. So we got the integrating factor if as 1 by y. So if I multiply equation 1 with the if integrating factor, and see what is equation 1 here. The question itself is the equation 1. So this is equation 1. So this value is 2xy plus e power x into dx minus, this is e power x by y into dy is equal to 0 is the equation 1. And therefore if I multiply throughout the equation with 1 by y, and see, this is going to become 2xy by y plus e power x by y into dx minus, this is e power x by y square into dy is equal to 0. If you multiply with the integrating factor, this non-exact differential equation is going to transform as an exact differential equation. So what is the formula for the solution? The solution formula here is integral m dx plus integral the terms not containing, the terms not containing x in n of dy is equal to 0. So here integral, so this value is going to turn as integral m. So if I cancel this one, this is going to become 2 2x plus e power x by y into dx plus the terms not containing x. There is a single terms which is containing x. So there are no terms which are not containing x, which is equal to 0. So if I want to make a integration with respect to x, this is 2 integration x square by 2 for e power x, this is e power x by y, which is equal to c. So if I cancel these two, the value here is e power x square plus e power x by y is equal to c. And now if I take y as an LCM, so this is going to become x square y plus x e power x is equal to cy. So this is the required solution, and this is how we have to solve. And this is also, so you can right till here also both are equal, and definitely this is how we have to solve and how we have to select the integrating factor. And this non-exact differential equation, we have to change it after multiplying with an integrating factor as an exact differential equation, and we have to put up in the formula, and definitely you can get a solution. And this differential equations chapter will be damn easy if you follow the playlist one after the other video. And if you really like, you know what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel and stay connected. And I'll be posting so many videos related to this series, and definitely the question will be flashing on the thumbnail, and definitely you can go into it and find the solution and practice well and score more. Thank you so much for watching and staying.